Hello there, fellow math enthusiasts. Mrs. Delzati here. Today we're taking a look at our transformation unit, Notes Day 7. We're going to be talking about rotations. So first of all, what a rotation is. A rotation is a rigid motion that goes ahead and it turns an object around a given point. We're going to see that with a rotation, congruency is preserved. So the size and the shape, they do not change. However, orientation is not preserved because the direction that it's facing gets altered. So we can go ahead, we can rotate in one of two ways. We can rotate clockwise, which we abbreviate as CW. Clockwise is the way that the hands go on a clock. We also have counterclockwise. Counterclockwise we abbreviate as CCW. And counterclockwise would be like a broken clock, so it's going backwards. Now, one thing to keep in mind is that there are 360 degrees in a circle. And when we rotate clockwise or counterclockwise, the two rotations should always add up to 360 degrees. All right, so here's what I mean by that. If we go ahead and we take a look at number 1, I want to figure out what rotation will take P to P prime. So I always like to try and do the short direction first. In this case, if I'm going from P to P prime in the short direction, this is the clockwise direction. It's going in the direction that the clock hands would follow. And I see that it is 60 degrees. Or I could go ahead and I can go from P to P prime. And I like this little circle here because I'm just going ahead and tracing over it. This would be my counterclockwise. Do you see how the purple and the pink together they make that full circle? Well, in order to figure out what the counterclockwise rotation is, all I have to do is subtract from 360. I could say 360 minus 60, and I will get 300 degrees. All right, let's take a look at number 2. To go from P to P prime. Well, notice that there really isn't a short way to go ahead and go. If I go this way versus this way, it's the same amounts. And notice that that's a straight line. How many degrees are in a straight line? There's 180. So if we talk about the clockwise rotation, that's 180 degrees. If we talk about the counterclockwise rotation, that is still 180 degrees. 180 and 180, we'll go ahead and we'll add up to 360. Now let's go ahead, let's take a look at number 3. I want to do the short way first. So to go from P to P prime, well, this is the counterclockwise rotation here. That is the 40 degrees. If we go around the long way, big circle there, that's the clockwise. To figure out the clockwise rotation, all we have to do is subtract off that 40 from 360, and we'll see that it is 320 degrees. All right, now we've got our picture ones where I'm going to give you an original picture, and I want to figure out which one is a rotation. All right, so one thing you could do is you could actually take your paper and rotate so you can go ahead, you can see what the flamingo is going to look like as it goes ahead and as it moves around. So if we were to take a look at A, well, A is actually just a reflection of the original, so A isn't what I want. If I were to go ahead and I were to take a look at B, think about the head moving this way, the feet moving up this way. B is going to be my rotation. Let's take a look at C though as well. C is actually just another reflection of that original, so C does not work. All right, looking at number 5, I have my original. Well, part A, it's in the exact same direction. A is an example of a translation. B, well, B, if I were to go ahead and reflect it over that dotted line, I would have B, so B is a reflection. And then C, if I tip the teddy bear on its side, C is going to be my rotation. Now, if we go ahead and we flip it over, we've got our rules of rotation. There's two different ones. I'm going to go ahead and I'm going to focus on this first one because I think it's the easiest one for us to go ahead and for us to work with. Now, if we're going to rotate 90 degrees or 270 degrees in either direction, what's going to happen is we're going to go ahead, we're going to take the X and the Y, and we're going to switch them. If we are rotating 180 degrees in either direction, we keep the X and Y the same. All right, and then one thing that we're going to see here is that we need to make sure that we have the proper signs attached, depending on what quadrant we're ending up in. Now, every quadrant is going to be worth 90 degrees because let's look at this here. Here's a 90-degree angle, here's a 90-degree angle, 90-degree angle, 90-degree angle. All right, each of those worth 90 degrees. So if we try and go ahead and rotate triangle MTV 90 degrees clockwise from the origin, that means in the clockwise rotation, we're moving one quadrant. This MTV is going to end up in quadrant 4. So how we do this is I'm going to first pull the original coordinates. M is 2, 8. T is 2, 3. V is 9, 3. M prime them. Since we are dealing with a 90-degree rotation, we take the 2 and the 8 and we switch them. But since we are in quadrant 4, in quadrant 4, all of the X values are positive, all of the Y values are negative, which means I have a positive 8 and I have to have a negative 2. Same thing with 2, 3. Let's switch the order. So it's now 3, 2. The X coordinates are positive, the Y coordinates are negative. And then for V, let's switch the order. We have 3, 9. The X coordinates are positive, the Y coordinates are negative. And we've just found our new coordinates here. So M prime is now at 8, negative 2. T prime is at 3, negative 2. And V prime is at 3, negative 9. I've gone ahead and I've rotated MTV 90 degrees about the origin, okay? Can you go ahead and can you kind of visualize that rotation there happening? All right, now number 7, I want to rotate NBC 270 degrees clockwise from the origin. Well, 270 degrees, take 270, put 90 into that, we get 3, which means we have to rotate 3 quadrants. So 1, 2, 3. The image is going to end up in the third quadrant. The third quadrant, keep in mind, has a negative X and a negative Y. So let's write down the original coordinates. N is negative 5, 2. B is negative 7, 9. And C is negative 2, 3. Now again, because this is a 90 or 270, we're going to switch the X and the Y coordinates. So let's not even worry about what the signs are. We're going to take the 5 and the 2, and we're just going to go ahead, we're going to switch them. That's going to turn into a 2 and a 5. They both need to be negative though because we're in that third quadrant. So negative 2 and negative 5. Let's do the same thing with the 7 and the 9. We'll go ahead, we'll switch the 2. And since we're in the third quadrant, they both have to be negative. And then that last one, 2, 3, let's go ahead, let's switch it. We've got 3 and 2, and since it's negative, or since we're in the third quadrant, both of those have to be negative. So N prime is negative 2, negative 5. B prime is -9, -7, and C prime is -3, -2. So if we go ahead, we connect those dots, we've completed the rotation there. Now, my last one, I want to rotate TBS 180 degrees counterclockwise. So I'm going in the opposite direction of the clock hands. Well, 180 divided by 90 is going to give me 2. So 1, 2. We're going to end up in that first quadrant. Keep in mind the coordinates in the first quadrant. We have a positive x and a positive y. So T's original coordinate is -7, -9. B's is -2, -3. And S is -3, -8. Now take a look up here. It says for 180 degrees, we keep the x and the y in the same order. So let's look at the 7 and the 9. Same order. They both have to be positive, so I don't have to change the signs on what I wrote originally there at all. For B, we keep the same order, 2 and 3. They both have to be positive. For S, we keep the same order, 3 and 8. And again, they both have to be positive. So let's go ahead, let's plot. T prime is 7, 9. B prime is 2, 3. And S prime is 3, 8. And I can go ahead, I can connect those dots. So those were our rotations. Keep in mind, a rotation, it will preserve congruency. However, orientation is not preserved. Del Zadi is done for today. I will see you in class.